Good afternoon and welcome to this Connect University crash course on large language models. If you have any question, please join Slido using the hashtag LLMS. And if you want to share any insight on social media, please also use the hashtag Connect University. The session will be recorded and will be available on the Digital EU YouTube channel and Futurium. Links will be added in the chat. If you are interested, join us also tomorrow on the Connect University session on communicating digital tech. Large language models are digital models of the human languages. They incorporate the knowledge present in the extensive amount of language data, being text or speech, used for their training. Their knowledge can be used in various ways for various applications, translation, text analysis, but also chatbots like ChatGPT, which can reproduce, so far imperfectly, the knowledge acquired during the training. We wanted this crash course to provide you with the necessary overview for you to better understand the limitation and opportunities these large language models offer. For that reason, we have an extremely packed program touching policy, basic concept, limitation, evaluation, legal aspect, data governance, ethical, and future application. I already present my excuse to the speakers for the sharp clock keeping I will need to show. But without any further delay, let me introduce the first speaker. Ivo Vollmann, our Director of Data within the Directorate General for Communication, Network, Content and Technology of the European Commission, and who will shed light on the European policies impacting language technologies. Thanks a lot. Ivo, the floor is yours.
Yes, good afternoon, everyone, and thanks, Philippe, for organizing this session on large language models. Now, also a very big thanks to all the speakers and, of course, also to the audience. Large language models, it's a topic that is close to my heart. It's fascinating and it's also timely. Now, why is it close to my heart? Well, ChatGPT may or may not know, but I wrote my PhD thesis on multilingualism of European law, hence my special interest in this topic. And actually, language technologies are the most European topic that we are handling. Being united in diversity, isn't at the core of the European project. Now, I combine this interest in languages with my role as director for data in DG Connect. And I know one thing for sure, large language models need data, huge quantities of data, billions of sentences, thousands of hours of speech that are needed. And this makes data really a crucial asset for what we're discussing today. Data access combined with computing power and the right algorithms will make things possible that were thought impossible until very recently, like breaking the human language barrier. And that's what is happening right now. It's surprising, but perhaps not completely, knowing that about 20% of investments in AI are spent on language technologies. Let me link this to the European Strategy for Data that we are responsible for. It was published in 2020, and it paved the way for Europe and European firms and Europeans to have control over the data they generate and to create also a genuine European market for data, a single market for data. An internal market where data collection and processing is done in line with European values, in line with European rules, where data can flow between countries, between sectors, really important, where there's ample of data available for use, including in language models, and where the rules of who can access data, what data, under which circumstances are clear. Now, we are combining their legislation, like the Data Governance Act that's in force already, the Data Act that's being negotiated, with funding actions. So policy and funding go hand in hand, really important there. And one of the objectives is to create common European data spaces where the infrastructures are in place to handle the data, but where also the governance is in place. So it must be clear who can access what data under which conditions. And one of these data spaces that the Commission is supporting is the Common European Language Data Space. Now, what is that going to be? It's a space for the collection, creation, sharing, and the reuse of multilingual and multimodal language data and models. It's a place where language resources can be shared, perhaps monetized, in full respect of EU principles and compliance with EU rules. Now, this language data space, it's not only going to provide large amounts of data that are really necessary to pre-train large language models, but also the high quality curated data that are necessary for fine-tuning these models to specific domains and applications. The language data space should answer a range of social and industrial needs, data needs, to build language solutions made in Europe for Europe. Now, this language data space is essential, but I would also like to mention for a moment something else, which is the need for state-of-the-art technology. And that's why we are supporting research in the field. It's about gaining a deeper understanding of how large language models work and how we can build the next generation of language models, ensuring an equal representation of all European languages. This is really strategically important for Europe. And these topics are being addressed already in the European Research Program, Horizon. We just had a call for proposals that had a very positive response on natural language understanding and human-machine interaction and language technologies. Now, so we will have some very interesting projects starting later this year. Now, there's one more thing I would like to mention, one more initiative. It's an initiative which brings together everything I mentioned, the previous work strands. It's called the Language EDIC. What's an EDIC? An EDIC is a European Digital Infrastructure Consortium. It's a new legal instrument under the Digital Decade Policy Program. And what does it do, this EDIC? It allows to pool financial and in-kind resources at European level together with resources from the member states. So it manages to combine EC funding and member states funding and efforts in multi-country projects that can support the digitalization of Europe. And there's one EDIC that's particularly relevant here, which is Language EDIC. It aims at achieving European sovereign capacity and strategic autonomy in language technologies. And of course, also for large language models. In short, the Language EDIC can be seen as a key element in Europe's response to the recent developments like ChatGPT. And there's more than 20 member states already interested in this EDIC. And it's the biggest in terms of contributions and collaborations by member states so far. It's in preparation, and it's going to support the collection of data, the development and the deployment of these European large language models, and of course, the corresponding applications and services across Europe. Okay, let's make sure. Let's make sure together that Europe-based language technologies and language data are at the basis of many new products and services. That's what we want. We want new opportunities for our companies, but at the same time, we want to cater for linguistic and cultural diversity in the Union. And let's make sure in this context that we are a player in all of this and not just the playing field. Thank you for your attention, and I'm looking forward to a very interesting session. Thanks again.
Thanks a lot, Ivo, for this introduction. Without further delay, let me introduce the first trio of speakers for the next presentation. Georges Rem has a background in computational linguistics and AI, is a principal researcher at the FKI and an adjunct professor at Humboldt University of Berlin. He's later participated in more than 40 national or European projects, including the language data space, the European language equality, the European language grid, and also Open GPT, a multilingual large language model. Pedro Ortiz is a researcher at the FKI and holds a PhD at INRIA and the Sorbonne University. He is the main researcher behind OSCAR project and has been involved in Big Science, the development of Bloom, another large language models, and also OpenGPTX. Finally, Malte Ostendorf is also a researcher at the FKI, holds a PhD at the University of Göttingen, involved in OpenGPTX, and developed a 6 billion parameter German large language model based on Blue. They will provide the overview, basic concept, and capabilities of the large language models. Dear speakers, the floor is yours.
Thank you very much, Philippe. We would like to briefly start the presentation with a look at the market. And this global natural language processing market, which is dominated by large language models as a foundational technology, is currently absolutely exploding. It's to be reach $340 billion by 2030. And what's noteworthy here is that these numbers are even pre-ChatGPT numbers. Yeah, by now this number is probably in the $400 or $500 billion region. So this area that we are talking about, natural language processing and large language models, is pretty dominated by players from the US and also China, reflecting also what Ivo Wollmann just presented in the introductory speech. And this is an issue for Europe, for European technological sovereignty. We've started already 10, 15 years ago, bringing together the community of language technology practitioners and NLP practitioners in Europe with a number of different projects and conference series and strategy recommendations. And as mentioned, our most recent endeavors have been European Language Grid, European Language Equality, and the aforementioned European Language Data Space. One of the projects was called Digital Language Equality or European Language Equality, but right now we still are at the level of digital language inequality. This graph here represents the support of our European languages through technologies, not only the official 24 EU member state languages, but also other languages, regional languages, minority languages, and except for English and to a certain extent, German, Spanish, and French, all European languages are massively under-resourced, especially in terms of data and also in terms of tools and technologies. And what we need to do in the future is unlock more data, more domain-specific data, new domain-specific data and data, especially for these under-resourced languages, so that the speakers of these languages also enjoy participating in the digital area. A few additional words on the European Language Data Space. This is a project started in January this year. It's going to be a 3+1 year project with the objective of developing and deploying a European platform and marketplace for the collection, creation, sharing, and reuse of multilingual and multimodal language data, which is the main ingredient of large language models. This is primarily directed towards industry and research, with the emphasis here on industry, but also including public administration, cultural associations, broadcasters, including public broadcasters, and various other stakeholders. And we collaborate, of course, with the Emerging Language EDIC. Having said that, I would like to hand over to my colleague Pedro Ortiz, who will take over the remainder of this presentation. Pedro.
Thank you, Georg. So now let's talk about large language models, how they are pre-trained and also fine-tuned for specific purposes. Next slide, please. Let's start by giving a simple definition of a language model. A language model is just a probability distribution over a sequence of words, which can be represented with this simple equation of a conditional probability, the one that you see on top. In this equation, we are computing the probability distribution for the next word or element, given a predefined sequence of words or a history, and also some model parameters. These models parameters will be learned from training the model on a very large data set and will define the distribution. Down to the left, we can see an example of a history that is given to a language model as an input. And to the right, we see the probabilities for the next word computed by the model. Here, brown is the most probable word after the history Alice painted her house. If we want to generate whole paragraphs, we just iterate over this procedure, predicting one word at a time. Next slide, please. Predicting the next word, given a context or a history, might seem like a very simple task, but this is a very general purpose task that can be used for question answering, translation, summarization, or even math, as it is shown here. This gives us a general purpose model that can be used in many different tasks. Next, please. Let's now see why we make these models large. Next slide. Here on the left, we see a graph showing how models are becoming larger and larger in number of parameters over the last few years. And on the right, we can see the estimate of the amount of words necessary to train a model of a given parameter size. Please note that the number of words is significantly higher than the number of parameters, now going into the hundreds of trillions. We will talk about this in a second. Next slide, please. But first, why do we make these models larger? Well, as you can see on the right, as we scale these general purpose models, they become more and more accurate in tasks such as arithmetic and translation. This is partly because we can roughly correlate the number of parameters with the memory of the model. The larger they are, the more data or knowledge they can store, and the more general the probability distribution will become. Now, we can increase the size of these models thanks to the transformer architecture, which was introduced in 2017 by Baswani. This architecture allows efficient scaling through efficient data parallelization. That is, the model can just ingest more data in parallel. Next slide, please. So let's now talk about pre-training and how we make these models general purpose through data. Next slide. So remember that these models are just predicting the next word on a sentence. So in order to make them general purpose, we need to train them with lots of data. As said previously, we are not working with trillions of words, which is now on a terabyte to a petabyte scale. To help you visualize how much data this is, the figure on the right shows a human next to the printed English Wikipedia, which is just 4 billion words. Thus, the datasets used to train these models are so big that we don't really have a way of manually auditing them and knowing what's inside. However, we do know that in order to make language models general purpose, the pre-training data should be diverse and balanced. Next slide, please. But are they diverse and balanced? Well, on the right, you can see the data distribution for the model Llama, which was recently developed by Meta AI. And as you can see, more than 80% of the training data comes from the web. This is because the web is cheap and easy to get, but the downside is that it is definitely nor diverse, nor balanced or representative. Moreover, web data also contains a lot of unwanted content. Aside from that, source code is also being used to pre-train these models, as well as books, encyclopedias, scientific literature, as you can see here on the table. Next slide, please. One important thing to say, and this is also stressing what Georg previously said, is that balancing the data is even harder for multilingual models. Here you can see the language distribution for the pre-training data for Bloom, a language model trained by the Big Science Workshop. As you can see, English is more than a third of the pre-training data. Then we have French, Spanish, and Chinese, each with less than a sixth of the data, and then some low resource languages massively underrepresented in the dataset. Next slide, please. Now, let's discuss how can we fine-tune these models for specific purposes. Next. We can fine-tune these models to follow instructions by training them on dataset of instruction answer pairs annotated by humans. Here, there is an example of two models trying to answer the question, where is the Eiffel Tower located? The non-fine-tuned model, that is the model that was just pre-trained with raw text, answers with another question. This is probably because somewhere on the pre-training dataset, it just went through a list of questions about the Eiffel Tower and is just completing the next word. However, the instruction fine-tuned model on the right provides the right answer to the question. Next slide, please. These models can be further fine-tuned for dialogue or conversations, again, with datasets of conversations between humans. Here on the left, we can see an example of a model fine-tuned only on instruction, which still produces the correct answer for where is the Eiffel Tower located, but fails to follow a simple conversation, not being able to resolve the reference of the it in how big is it, still referring to the Eiffel Tower, of course. By contrast, on the right, the dialogue fine-tuned model is capable of answering both questions while also giving more information and more natural, nuanced responses. Next, please. So, in conclusion, a language model is just a statistical model that is trying to predict the next word. This simple task makes them very flexible, allowing us to use them and even fine-tune them for many different tasks and use cases. However, developing general language models require massive amounts of data and computational resources. And as previously said, it is still a challenge to make the data balanced, diverse, and representative for this model, especially if we want to work with multilingual data. Thank you.
Thanks a lot. I think that we have the time actually for a question. And the question would be, how do we expect the large language models built from data in the European language data space to compare in terms of size and performance to those developed by large US companies? That's a provocating question. Pedro or George, if you want to try to answer that question.
Yeah, it's a provocative question, but it's also a question that is difficult to respond to, yeah, because we don't really know anything about the data that the popular models like ChatGPT have been trained on. So we have zero information about this. There are vague documents published by the company that did this, OpenAI, in which they only provide some vague information, but we don't have any concrete indication about the actual size. So this is all speculation territory. With the language data space, our ambition is to unlock data that is currently not easily accessible. Yeah, so web data can be easily scraped. I know it's a legal gray area. Let's ignore this for a second. We want to unlock data from stakeholders that does exist in digital form, yeah, that can be perhaps with the right curation be made available through the language data space in a way so that the data providers, the data donors remain in charge of their data, but still maybe with approaches like federated learning, we can access the data for training language models. Yeah, so in a way, that we have like national corpora almost in a way, like in linguistics back in the 80s and 90s, where we have national data sets in a way, yeah, as a metaphor, that can be taken and then put into the training data for one of our large language models. Yeah, this is a bit in the future, obviously, but this is our ambition.
Thank you,
comments?
George. We actually have an even more provocative question, I see. It's web data is cheaper till you get sued by copyright owner, isn't it? And I know that we will have a legal aspect a little bit later, but I guess that if you want to answer, I mean, or I answer on your behalf, and you would basically answer, yes, of course. And I mean that copyright is an essential aspect, and we need to keep track of this one, being within the research sphere or within the industrial sphere.
Mm-hmm. Yeah, maybe one quick comment on this. In the grander scheme of things, we are in a transition period from my point of view. So there are approaches to lock your data using robots.txt, for example, from crawlers so that your data available on your website isn't crawled. Many robots, many crawlers simply disregard that information and crawl anyway. In the future, what I perceive, maybe in 3 to 4 years, There will be standards in place, and this is now work that will start pretty soon, I guess. There are various initiatives already, but it will take off soon, there's no doubt. So that data providers, so let's say website maintainers, will be able to specify on a fine-grained level what kind of data can be crawled and can be used for training language models. This has become prominent, especially with large image models, and there are various lawsuits now going on. And one technical solution for this is a standard that will be respected so that data providers can say and specify what kind of data can be used for which specific purpose.
Thanks a lot, George. And I have another, a little bit more technical question, which is it possible, and if so, how, to create large language models that can be safe and non-discriminatory by design? And the person was thinking about gender stereotype and harmful content.
Maybe I can say a word about that, and this is something that it's right now quite difficult, and that is also in part product of the training data that we are feeding these models. So as you saw on the example, 80%, sometimes 80% of the training data for these models come from the web. And the problem of using web data is that, yes, as we said, it's cheap, it's easy to get, but it's also full of unwanted content that you don't want. And these models tend to, of course, they are just predicting the next word. These models tend to reproduce and amplify. So what you have to do, or what we are trying to do right now, which is, I mean, that's another discussion, but it's maybe not the right way to go, is that on the fine-tuning in the instruction, on the dialogue, what you have to do is that you have to tell, like, you have to feed a lot of annotated data to the model, saying, don't say that, don't do that, don't answer like this, answer like this. So you have to show the model more examples in order to avoid those harmful responses. Maybe, and the hope with something like these initiatives, like the language data space, is that, yes, we have a steeper hill to climb in a way because of multilinguality in the European Union and also because of the quantity of data. But the advantage in a way is that, or my hope is that the data that is going to be exchanged is more well documented, more annotated, and we will have more idea of what's inside. So we can expect better outcomes of those models.
Thank you, Pedro. Maybe a last question, which is, what do you meant exactly with curated data? How can you be sure about the quality of the data used to train the large language models?
So that is something that is, again, when you are using these massive amounts of data, it's something that is very difficult to do. So what we are doing right now, and the work remains in the very, very low level. So what we are trying to remove from those data sets are things like repetition, so noise, because, for instance, when you look at web data and you download web data from the web, the data is extremely noisy, full of punctuation, full of things that is not linguistically relevant. So what we are doing right now is try to remove that. We are also trying to remove some of those websites that we know of that might contain some unwanted content, but this is something done through just lists, like block lists that exist of the web that we were already using for, let's say, in high schools or classrooms and things like that to protect the children. Now we are using it to don't feed this data to the models. But again, this is something that is not extensive. The data sets that we are feeding these things are massive, and doing quality control is still an open question and still an ongoing area of research that we will have to work a lot on.
Thank you, Pedro. I cannot refrain adding a last question, very last one. It's actually on the famous prompt engineering. So the person said, my understanding is that fine-tuning is done based on prompt engineering. How this is performed in practice and retained based on data sets with, how does it perform in practice, basically?
Maybe, okay. So, for instance, when we gave the example of the instruction fine-tune model, what is happening with prompt engineering is that you are almost trying to mimic the data set that was used to train the model. So again, these models are just predicting the next word, it's like a very expensive autocomplete. And what you are doing with prompt engineering is just trying to guess what was in the fine-tuning data for instructions or for dialogue and trying to ask the exact same question that was there. So this is more or less what prompt engineering has become of. What we are doing right now is that the data sets are becoming a little bit more nuanced, so you have multiple different ways of asking the same question. And this avoids kind of this prompt engineering requirement where you have to really think of the question and how you write it in order for the model to respond correctly. That's more or less an idea.
Thank you, Pedro. So now, without any further delay, I would suggest to go to the next speaker. André Boyard has a background on machine and speech translation, summarization, and evaluation. He is an associated professor at Charles University. He has worked on several European research projects handling machine translation, human interaction, and lately on the speech application. He is also co-organizer of the World Machine Translation Conference since 2013 and the International Conference on Spoken Language Translation since 2020. Finally, he is also dealing with automatic summarization of meeting transcript, AutoMin, since 2021 and 2023. André is going to talk about the limitation and evaluation of the large language model. André, the floor is yours.
Yeah, Philip, thank you very much. And thanks to everybody for inviting me. Indeed, I'm from the area of primarily machine translation, and I feel confident talking about large language models because there are two commonalities. First of all, machine translation has grown as big as it was or as good as it is, thanks to the large data that we have collected, the text previously translated by humans, and also the architecture, which has totally revolutionized the quality in machine translation, is the transformer architecture, the very one which is behind all the large language models today. So what I'm going to talk about is the evaluation. And as mentioned, I was involved in the WMT workshops, the regular annual shared tasks on evaluating machine translation quality. And thanks to the more than a decade and a half of yearly evaluations, we were able to get the translation to the quality where it is. So the standard approach is that you have some training data and then some development data and then some test data. So that's train, dev, test approach. And we use this regularly because we want to know the performance of our systems when we apply them for real on some new data. So the approach that we have always followed is that we were trying to guarantee that the test data will be independent from the training data. So if we go on the next slide, then you will see that in the training data, which is the big cylinder on the left, there are some documents, and these documents they contain some sentences, and we have selected the 4 red colored sentences as our test set. And we have, because we were in full control of that, we have carefully removed these sentences from the training data. This way, you train the model, and you are sure that you are testing it in some new conditions. This is the ideal situation. The independent and identically distributed examples. So you are selecting sentences that are very close to the sentences that were in the training data, but that are novel. There is a little catch though. So we have selected these test sentences from all the documents, and that way, when, for example, a document was talking about the Red Riding Hood, we have selected some sentences that mention Red Riding Hood, and the model would know what is the correct translation of the Little Red Riding Hood in Czech language, for example. A more realistic setting is, if you go on the next slide, to extract full documents, because you want your system to be good also on other fairy tales, not just the Little Red Riding Hood. So you should not be selecting individual sentences, but you should be selecting full documents. So this is the approach. And again, you see that in the training data, I no longer have the red colored documents. I have removed them. And this is what I'll be testing the model for. So if we go then on the next slide, we will see the situation that we have with the models accessible through API or pre-trained models. We simply do not know what is in the training data. There could be documents which are very similar to or there could be sentences that are very similar to the ones that you are testing on, and you cannot ask the model what was the model trained on. People have put a lot of effort into the development of the training sets and also the test sets. So I would like to mention, for example, one, it's called Big Bench dataset. That's a test set which is very diverse. And the authors of this test set are aware of the fact that as soon as anything of this test set leaks into the training data, again, the model can simply copy what is in there. It doesn't have to show any generalization capacity. So they ask, the authors of Big Bench, ask everybody to avoid the documents that are in their carefully curated test set. So they have introduced the idea of canary strings, some small indicators. You are looking at the one for the Big Bench. So the idea is that whoever is crawling the web, they should obey not only the robots.txt file or any other licensing constraint, but they should further on remove all the documents which happen to have this this strange label. There is a catch, though, that many of these source documents that were additionally curated for the Big Bench use actually appeared elsewhere. And that's a similar situation with the copyrighted data. If you are carefully following the robots.txt and you are avoiding any copyrighted data based on that, there could be some users who have just taken a picture of that or copied that, and through some other source, the exact same instance will actually get your training data without you knowing that. So that's a big problem with models that are a black box. It's very difficult to create test sets that are independent of the training data. And if we go on the next slide, we will see what we actually have. The situation is much worse. These current models, the large language models, are trained on everything. So whatever you can come up with is probably written somewhere by someone on the internet. And it's very likely part of the training data of these models. Even great minds think alike. So many of the test cases that we will be now inventing are essentially just a rediscovery of something which someone else has already discovered. And we cannot extract those difficult examples from the training data because we don't have access to the training data at all. And furthermore, if everything is included, everything that people have written so far is included in the training data, it's very difficult to come up with novel things. So generating these novel test cases is, to me, like reaching the speed of light. It's getting more and more expensive. You need to exert more power. So I'm concluding this part with a question whether testing for generalization is actually impossible. And let's go on the next slide. And this illustrates how flaky, how bad transformers are in terms of generalization. So this is, again, the machine translation exercise. And this is translation from English into Czech. And we have trained on a corpus which was somewhat limited to the sentence length. So what you see on the x-axis is the test set sentence lengths, and what you see on the y-axis is some approximation of the translation quality. And overall, the translation quality is between 15 and 20, whatever the scale is. That's the black line on top, and that's when you train your model on everything, on sentences of all lengths. If you train your model only on sentences which are up to 10 words, that is the light blue line, that starts pretty high but declines very quickly. If you train on sentences from the bucket from 10 to 20, then you are very good on short sentences of 10 words, but again, testing on any longer sentences, the performance degrades. And similarly, if you look in the middle on the green hill, that's a model which was trained on sentences of 30 to 40 words. And again, this model performs best on sentences on 40 words. The reason is that the model, the vanilla transformer, is unable to produce sentences of length different from the training data. If we go on the next slide, we will see that this is actually worse. You would assume that the model cannot extrapolate. The thing is, the model cannot even interpolate. This is the sentence length that the model is producing when it was trained on two buckets, on sentences 10 to 20 and 40 to 50. It is producing sentences in both of these areas, but it doesn't produce sentences of the mid-range. Again, we can move on the next slide. So I'm talking about wishful thinking now. There is one problem with evaluation. I've touched upon that. The other one is that, of course, people can be forging scientific results, but I don't really, I'm not worried about that. There are like techniques how to avoid forging results. But the problem is if even with full honesty, you are misinterpreting the gains that you are getting. So wishful thinking is detrimental for the whole field because this wrong explanation will mislead others. Wrongly explained gains cannot be reproduced outside of the very same settings, and whole fields could be built upon these wrong interpretations. Let's go for an example on the next slide. Here, we as computational linguists are very fond of syntactic structure. So we were hoping that machine translation could be improved by feeding in this linguistically annotated relevant data, the syntactic structure. So we trained our models to also consider the source or target syntax, essentially emit it for free, and we saw gains. So if you look at the plot there, which is the learning curve, the baseline is the blue model, and the translation quality on the y-axis gets higher. That's the red line there, when the model was also considering syntax. That's great. We did an experiment on the next slide. This highlights what happens when we injected not the true linguistically motivated syntax, but some random syntactic labels. And this random syntax helped almost equally as much as the correct syntax did help. So the main lesson to learn from this is that with these complex models, you can easily get some gain for some other unexpected, like numerical properties. You implicitly do some regularization of the model or whatever. You introduce some extra free parameters and the model abuses them and you don't realize that. So what I'm calling for is what I call stupid baselines. You always should complement your experiments with something which is very random and it just mimics what you are trying to do, but without providing the actual data. And often you will get a similar picture. You will get a similar improvement. So yeah, let's move on to the next slide. Here is a warning about fine print in various papers. I don't have the time to go into the details, but Google has had a blog post, a combination of 4 papers. They have these massively multilingual massive models. On the plot, you can see the performance of these models on 100 languages, always translating from that language to English. In the left-hand side is high resource languages. In the right-hand side in the plot, it's low resource languages. And the baseline is the black line. That's the pairwise models that only translate for the given language. So from the given language into English. And it has been always known that multilingual models perform well for low resource languages. They help them. And the problem was that high resource languages have always suffered. So Google have increased the model size to 50 billion parameters. And that's the blue curve in the plot, where there is indeed a gain even for high resource languages. It's not a big surprise to me that 100 times bigger model can accommodate 100 language pairs. But the problem is that the baseline remained the bilingual model of the small size. So I claim that in those evaluations, Google should have also used this 50 billion model for just individual language pairs, and they would get the claim as well. So if claiming that growing the models helps in performance, that is good. But if the claim would be using small resource languages to help the big resource languages, that could easily be a misexplanation because the gain comes only from the size. Let's move on to the next slide. So I see a lot of wishful thinking about large language models in the public as well. People are unaware of the technology and they assume too much about the large language models. So I think that when cars were introduced, they were moving too quickly and everybody could think that with this speed they could fly. Of course, we now know that cars don't fly, and if they do, it's not really a voluntary activity. So people trust the models too much. If the model says something like, I've considered these sources and I've done my calculations and now I'm presenting the result, people trust these side messages, but as of now, the model has no capability of actually doing so. So I think that understanding the internal ones, kind of the physics of the driving of these models, is the best vaccination against against such unrealistic assumptions. So we can conclude on the last slide of mine deck. Yeah. So the train, development, and test set approach is failing for large language models, and that's because closed models cannot be reliably tested. You don't know what is in the training data. Maybe they have only seen that, they are just repeated what they have memorized. The LLMs models make also the generalization extremely expensive, like testing for generalization, because you need to come up with new things, and with so vast training data, very likely you are just finding something that someone else has already written down. So for that reason, I maintain that claims on generalization capabilities are non-verifiable with the large language models. Transformers, on the other hand, can be very brittle. They fail to generalize over sentence length. Some other research that we also did, they fail to copy sentences longer than what was seen in the training data. So it's like at many places, there will be very brittle failures for generalization that we would never expect from these clever models to suffer from. Gains can be observed from unexpected and unexplained reasons, and that would mislead the field. So trivial baselines or stupid baselines should be always used, but they are not a common practice. And yes, 100 times bigger models accommodate 100 languages, but the gain could be established only thanks to the bigger size of the model and not because of the multilinguality. So we should again test it with the appropriately sized baseline model. So last comment is that when we all would put all our research eggs into the OpenAI basket, we would actually damage the parallelism of science, of research, and that is very risky in the long term. Thank you.
Thanks a lot, Andrej. There is actually a lot of questions, and some of the fundamental one I will keep it for the end of all the presentation if we have time. But there is a few that I think that you would like to answer. One of them is how to make sure that the training data is reliable. If a large part of the web is written by flat earthers, then it will be part of the training.
That's it. So I think that all the claims for generalization that we are seeing are essentially just random spots. Like we're stepping on the training data. We are just finding what has been in the training data in some pattern matching way. Of course, it's no longer like simple string matching. The models are very advanced. I'm not denying that. So the similarity between the patterns can be very subtle. We would not see it as by just comparing the sequences of words. But I think that that the size of the data makes it very easy for the model to fool us. A side remark is the prompting. So when people prompt, Pedro very correctly said, or I share the same view as he has, with prompting, you're essentially trying to find what was in the training data so that the continuation predicted by the model is the one that was in the training data. So you're, when prompting, you're essentially reverse engineering, you're guessing what could have been discussed in the training data so that you get better response.
Thank you. I'm trying to monitor the question, and they came on the fly. There is an interesting one. I'm sorry for the one that I'm not catching. Is it realistic to expect that large language model providers can provide a service which answer the question, is sentence X in my training data?
I would say, why not? Like, it's just up to them. So they surely have the data. So it would be only us researchers who would have so limited resources that we would be like training while downloading, and we would not have the capacity of keeping the copy. But the large companies have the capacity, so they should keep the copy and be able to respond to these questions.
Okay, and maybe a last question is what is really the applicability of large language model to machine translation?
That is an excellent question. it's very diverse. So the large language models, the transformer there is actually used only like the second part of the transformer, only the decoder. It's an encoder of the source language and then the decoder. And for well-covered languages, languages which happened to be in the training data represented a lot, so that is languages which were represented in the internet a lot, the large language model knows very well what a fluent sentence in Czech looks like. So for the high resource languages, LLMs produce better translation quality than the standard direct translation models, even if it's the same transformer architecture. And that's because they do not suffer so much from the translationese effect. When we are training the standard transformers on parallel documents, so text where humans had some source, a human produced the target, and the transformer learns to map that, humans themselves have already kept some traits of the source language. That's called translationese. So the Czech which comes from English is not so fluent Czech as the Czech read elsewhere. That's the benefit for the large language models for the high resource languages. For the low resource languages, they perform worse and will always be worse than like specific models.
Thanks a lot, Andrei. Now, looking at the timing and without any further delay, I propose to introduce the next speakers. Michael Rigaud. Michael is a legal professional with 7 years of experience in intellectual property within the media and entertainment companies. He has been working on a legal expert at the European Language Data Association and the Language Resource Association for the last 4 years. He has expertise in intellectual property and data protection issues related to language data and language modeling. He has also contributed as a legal expert in several European projects like ATCO, ELG, LRC, LTS, and MAPA. He will talk about legal aspects in a nutshell. Michael, the floor is yours.
Thank you, Philip. And let's dive right in and start with some general intellectual property concepts. So, intellectual property law grants exclusive right to owners, whether it be into original content, such as text, audio, or video, or into databases. And these exclusive rights include the rights to distribute, modify, or use content for any purpose. And that includes like the right to train language models. These rights can be granted by the owners to user, either through proprietary license that would be negotiated usually for a fee between a user and the owner, or through permissive licenses, such as Creative Commons, MIT, and others. And as the other speakers previously mentioned, when we talk about large language models, we talk about large amounts of data, which can make the licensing costs prohibitive or the availability of open data difficult. Next, please. So that's why exceptions have been granted for data collection on the internet. In the EU, this has been made possible thanks to the implementation of the text and data mining exception in 2019. This exception is twofold: one for general matters, and including industrial use, and other for scientific research. Both of these exceptions are conditioned on a condition of lawful access to the original content. As a point of comparison, we can also point to the fair use doctrine that is in place in the US under Section 107 of the Copyright Code, which allows reuse of copyrighted content under the 4 conditions detailed below. Next, please. In addition to protection of intellectual property, the other main issue that I wanted to touch upon is protection of personal data. And here we are mostly focusing on what is happening on the European landscape with the GDPR. So GDPR is the General Data Protection Regulation, and it's based on 3 main pillars that you can see on the table below. So the GDPR states main data protection principle that you can see on the left-hand side. It provides for rights for data subject with regard to their own personal data, and it provides for legal basis under which personal data can be processed. And I wanted to focus on one key aspect of GDPR, which is accountability. The accountability principle is the overarching principle of personal data protection. It mandates that the responsible entity for data processing has to be compliant with all the other principles that are in place in the table. It has to be compliant with all the principles that are stated by GDPR. It has to be allow data subject to exercise their rights according to GDPR, and it has to have a legal basis to perform personal data processing. Next, please. So, with regards to the concept that we established above, there are some legal. We can see that there are some legal challenges for based from LLM. So there are some intellectual property constraints. There are questions regarding compensation of copyright owner regarding to their collected data. There can be traceability issues with regards to the different types of licensing used with regards to content. There are also data protection concerns. Pedro mentioned that there were some difficulty to audit the data that was contained that we use for training, and that can cause practical difficulties for users to exercise their rights under GDPR. There also can be a contradiction with the data minimization principle that was that is enforced by GDPR, and that can also be difficulty with regards to the legal basis for processing activities. For example, OpenAI uses the legitimate interest as its basis for processing data for their activities. That's why I wanted to touch on the next slide on some recent case law related to LLMs. And here we can find some good points of comparisons. So in the European landscape, you may have been aware of the recent ban of ChatGPT in Italy. This ban was based on the fact that OpenAI provided no information and no legal basis for the processing of training data, and the fact that they processed inaccurate personal data and performed no age verification that allowed minors to access the service. This ban triggered the launch of a task force led by the European Data Protection Board, which is the collection of all national supervisory authority to assess ChatGPT GDPR compliance. And that is currently ongoing at the moment. In the US, there is also an ongoing class action lawsuit based more on intellectual property concern. And it's based on the fact that OpenAI crawled ChatGPT GitHub repositories to feed code generation AI, which in turn provided to its user code in breach of open source license, with the fact that they withheld the attribution requirements and that they removed the copyright information such as the license X from these open source licenses. On its part, OpenAI claims that the crawling performed from GitHub is performed under the fair use doctrine that I've mentioned previously. And from this case law, we can see that the legal landscape is moving as fast and trying to play catch up with the technology or tech development. And I would like to hand on this end. Thank you.
Thanks a lot, Michael. I think that we are going to jump directly to the next speaker, if you don't mind. Anna Rogers. Anna is a researcher in natural language processing and assistant professor at IT University of Copenhagen. She has done a postdoc at University of Copenhagen and also University of Massachusetts. She holds a PhD from the University of Tokyo. And she has provided a major contribution in the analysis of mask language models within the BERT model. If you remember the people in the domain, these are already ancestors, I would say, models. Time is flying. She worked in natural language understanding, benchmark, and self-regulation effort in academic NLP. She is also a program chair of ACL, the Association for Computational Linguists Conference. It's a major conference at the domain. And she has also been involved in the Big Science and the Bloom project, so creation of the large language model. Anne will talk about data governance. Anne, the floor is yours.
We can't hear you.
Thank you for the invitation, and thank you for the introduction. Could I have my first slide? I guess my talk starts right where we just left off with the legal issues. The way I tend to think of it is that the development of large language models so far was following this ethos of what you see is yours to take. Everything that is public is yours and can be used under this fair use doctrine. And it doesn't matter whether it's personal data, doesn't matter that you haven't taken consent. And as we just heard, legal troubles start coming for OpenAI. Yes, there's a piracy lawsuit over Copilot. There's a class action lawsuit by the artists. There's the GDPR concerns, and even Japan recently joined the line of people who are concerned. But I think one more point that is worth mentioning here is that it's not just that OpenAI and Microsoft claim fair use, it's that they basically put the burden of proof on the plaintiffs. So in case of the Copilot, the rationale is basically that the plaintiffs failed to show that their specific code was taken and that they suffered specific damages as a result of that. And of course, they can't do that unless people have access to the training data of the language models, which means that nobody ever can touch them on this. Could I have my next slide, please? The point I'd like to make in this talk is that it doesn't have to be this way. And Big Science was an effort, and I think still is state of the art in just showing that, yes, things can be done differently. It was a very big collaboration of over 1,000 researchers from 60 countries. It was in large part possible thanks to the support of European infrastructure, in particular the French government and the Agence supercomputer. And the result is still the largest open, not open source, but open weight model that is multilingual and available today. And more than that, apart from all this model stuff, there's also extensive evaluations, there's training data documentation, there's an effort to come up with a do no harm license, and there is a model of data governance that was also a result of this project, and this is what I'd like to show today. And this was a big collaboration between not just NLP researchers like myself, but ethicists and lawyers. There were many, many people involved, and the data governance group was led by Margaret Mitchell, that you may remember her as one of those Google ethicists who were fired over the stochastic parrots paper. And the data governance paper that the results of which I will present now was led by Yasin Yernit. Next slide, please. So the rationale for this project was to discard this ethos of what you see is yours to take. We didn't want to see just how far we could push what is possible, what is legally agrees on, but like, what do we want to do with LLM development? What values would we like to implement? Next slide, please. And these are the values that we decided after lots of discussion that we would like to try to implement. So inclusion, representation, non-discrimination, local knowledge, participation, autonomy, privacy. There was an honest effort on the part of Big Science team to try to do something about all of these. Next slide, please. And the way that this was implemented was in this proposed data governance model for LLMs, which This is quite a busy slide, but maybe let's go through it from left to right. So we start with the data modelers. These are the people who want to have the data and do something with the data. Instead of going directly to the source, they actually go to the data stewardship organization, and that's the space, I guess, akin to what this European language space will be. This is a space which serves as an umbrella space for everything data related, and also as a discussion space for how things should morph as we figure out this very complex and nascent field. On the other side of the data stewardship organization, you see the data hosts, and these are the people who have the infrastructure to provide the data to the modelers, but they are not the people who are authors of the data. The data providers, who are on the far right of the chart, these are the entities or individuals who actually have the rights to the data, and they interface with the data hosts through agreements in which they specify how they want the data to be used. And this way we have the entire pipeline from modelers to data rights holders, which supposedly makes it possible to respect everybody's wishes and concerns. Next slide, please. So let's start with the value of local knowledge. And this is, of course, maybe the only way in which it is possible. And I guess this is also something that will be happening in the European language data space. These local entities, maybe libraries, maybe archives, maybe local, maybe individuals, they are the only ones who know what the data is. And so they are in the best position to say how they want the data to be used. Maybe they want to disallow commercial use, maybe they want to allow it under certain exceptions. But this is the structure through which this local knowledge value is implemented. Next slide, please. Then we go to the just rewards and licensing and attribution, and all of this is possible with the same mechanism. When people say, I want to allow my data to be used in this way, I can also say, like, what do I want to get if it is used commercially? And then if we have a uniform framework with all these licenses and agreements, then on the other side, the data modelers can say, okay, this I can afford, this I cannot afford, and this I am allowed to use under the existing restrictions. Next slide, please. The value of participation is implemented in this umbrella space, which is the space for ongoing discussion for all parties. The modelers need to be able to say what they need, so that this is effectively communicated to the data providers. And this whole field, as I said, is nascent, so there is constant ongoing negotiation, also with the help of hopefully lawyers and rights advocates and diversity representatives. All of this is probably going to be negotiated over the next many, many years. Next slide, please. So for the value of privacy, there's several mechanisms. First, the data providers themselves can decide that something is too personal to provide. Probably nobody wants to provide their medical data or something like that. And then these agreements, they can also specify actually restrictions on the pre-processing that data has to go through before it gets to the modelers. So, for example, I want to allow this data to be used, let's say my archive of something, but I want for anybody who uses this data, who gets this data from the data host, I want them to be under obligation to remove certain things like addresses. So that can be specified. Because even defining what is private and personal and the tools that allow successful obfuscation, all of this is under development. So this also keeps being defined in the DSO as time goes on. Next slide, please. For the autonomy, consent, and contestation, we have our data providers who originally provided their data, but if it's some kind of archive which is not collected based on consent, then we need, of course, according to the GDPR, to enable people to request their removal. So the removal would be happening at the data host level. So let's say the local library who initially provided the data to the data host, they keep their copy as it was, but the data hosts, after they receive the contestation request, they are under obligation to remove that piece of data from their copy, and from that point on, they will be only providing the modified copy. This is what any future modelers will get. I guess it is also possible to use these requests as some kind of request for a simple filter, at least, of the output of already trained models, so that we can say, okay, like this address should never be outputted, period. And maybe we can develop an infrastructure for something like that. Next slide, please. So the value of beneficence, we try to implement through a new license, what is called Responsible AI License, or RAIL. It is not an open source license, and the open source community was sometimes not very enthusiastic about Bloom because of this, but the core idea here is that you restrict the model from certain uses which you want to disallow. In our case, we came up with these lists based on our own internal discussions. Ideally, I guess these lists would somehow trickle down from the values that, from the restrictions that also the original data providers were imposing on the final product of the model. So, for example, RAIL states that the people who use Bloom cannot use it to violate applicable laws, to exploit or harm minors, to disseminate verifiably false information, which basically means no language modeling, to disseminate personal identifiable information, something that is provided without a disclaimer that it is a synthetic text, something that is disparaging, impersonating. All of this is just prohibited. Next slide, please. And likewise, this model is not to be used for fully automated decision-making, for something that can have discrimination effect, to exploit vulnerabilities of any specific group, for providing medical advice, because this was never the intended goal, or something that is that can be used for administration of justice, law enforcement, and something like that. So one could argue about the specific list that Bloom came up with, but the idea is that all of these restrictions are just in the license. And of course, if somebody is a bad actor and they want to download the model and use it in this way, they can. But so this is the a license is only as good as people's intention of observing it, but at least they would be breaking the license, and maybe in the future we will have some mechanisms for enforcing that. Next slide, please. Now, for the value of inclusion, representation, and non-discrimination, as I said, Big Science was a really big effort by 1,000 researchers, and there was a really, really big effort to just try to reach out to many, many different communities and to try to get people to contribute to nominate resources for their languages. This was implemented through data sourcing hackathons. This work was led by Angelina Major, and the idea was that there would be open calls disseminated through personal networks and also through public, through Twitter and such. And the representatives of different language communities would be asked to participate and to nominate resources that would be good resources to represent their language. So we were able to involve the African community, the community for Asian languages with Machine Learning Tokyo, Basque, Latinx was a very active contributor. As a result, we were able to collect a catalog of sources that these people nominated. Could I have the next slide, please? So as an example, there is a a catalog. There's a link on my slide, and you could browse this catalog by by selecting the constraints on like what are the restrictions on the data, where the data came from, and you can just see whether this country, how many resources you have for this country, basically. Next slide, please. There is extensive metadata that also people collected through these hackathons, so you can see where the data came from and who are the custodians, etc. Next slide, please. An important caveat is that even with 1,000 people who worked for a year and tried to get all the resources we could, we still weren't able to collect as much data as we needed to train Bloom. And in the end, we still had to use 38% of a web crawl data set, Oscar, developed by Pedro here. This is, I guess, a takeaway that is important for the European Commission. We need support, we need infrastructure, we need more resources for data curation and collection on scale. But still, even without any support, this is how much we were able to collect. And this, I think, is good tidings for what could happen with more support. Next slide, please. To go back to the earlier point about how possible is it to say that something was in the training data or not, to evaluate models fairly, it is absolutely possible. We have developed this for Bloom. Here's a search tool that contains the full, that has the index for full Bloom search training data, 1.6 terabytes of text. And anybody right now can go and look up any string, and people have already identified benchmarks which should not be used for Bloom because it was contaminated. So next slide, please. So that's what I have. LLM development does not have to be evil. There is a lot of goodwill and support around the globe, and there's many researchers who are willing to work on this. Everything that I said today, this is kind of results of us building the plane as we flying it. None of this is perfect, but with more support, I'm confident that much more beneficent and kind language models could be developed. Thank you very much.
Thanks a lot, Anna. There has been a few questions, if you don't mind. One of them is actually, what was the mandate of the Data Stewardship Organization Committee? Who was invited to participate? How was participation from stakeholder group decided?
I need to say here that this data governance group, it was happening in parallel with the rest of the development of Bloom, right? So this is more of a prototype. And the people who participated in all of this, these are the people who were developing the model. And we knew from the very start that like this project would not be forever. This was a one-year workshop. But if something like this was to happen with real resources of that you have at your disposal, then of course, I guess it would be something with a broad mandate, and you would invite representatives of everybody who is in any way concerned and involved or can be affected. Yeah, that's what I have.
Thank you. And I also have another question, which is actually a little bit more technical. The recent open source large language model like Falcon are using Apache 2.0 license. How does Rail and Apache 2.0 compare? If you can,
Well, Apache 2.0 is an actual open source license. So you have restrictions on, I think, contribution or something like that. But Rail is special in that it explicitly prohibits certain uses, certain kinds of uses. And this, I think, is quite unique.
Okay, then a last question before we go to the next speakers is actually, would the big Bloom's version be made available as an option in the Hugging Chat application? I think Hugging Face was a big participant, backer of the project. Are you aware of any move in that direction?
What do you mean available? They are available.
In the Hugging Chat application.
Oh, as in an actual application that is hosted for people to use. I don't know that anybody is planning to do that. Again, what is OpenAI is doing this because they're selling the model, obviously, and they have the infrastructure to do this. For us, even to have this interface for searching the training data, like these are resources that at the moment are kindly provided by someone, and I don't know for how long that can last. So, of course, somebody could put up blooms or anything else. It's the case of somebody backing it up with their resources and support.
Then maybe a very last question is, how did the data sourcing hackathons work in practice? Would you recommend that as a way to gather new data sets?
So this was not it was not data collection as such. It was not annotation. It was collection of resources nominated by the people who participated in the hackathon, right? So, for example, I speak French, and I know that there are these and these and these resources which could be used. So I come and I say, okay, these are the resources, and I try to, as best I can, to document them. But this is not like collecting data sets from scratch by themselves, right? I think as far as reusing existing resources, this is absolutely the way to go. And of course, there are many resources which are available and more or less structured and documented, and we want to use them. And I do think this is a good way to unlock them and to bring them to a format that is well documented. And here, Hugging Face, I think, did a great job of actually developing this sample catalog with currently over 500 resources, which can be continued and extended, and this is all open and open source.
Thanks a lot, Anna, for the presentation and the extensive answer to the extensive question, but that shows all the interest of the audience, you see. I'm going now to go to the next speaker, and I do hope that Karen is among us. Karen Ford is actually an associated professor at Sorbonne University in Paris and researcher at Loya. She has previous experience in the industry, has expertise in language resources from natural language processing and game with a purpose. She's also co-chair of the Ethic Committee. She worked in crowdsourcing for NLP, published stereotyped bias in LLM, and big tech in NLP. She will talk about bias and other ethical aspects. Karen, the floor is yours.
Thank you very much. I hope you can hear me.
We do.
Okay, that's great. Thank you. Due to technical issues, I'm only here with my voice, but I'm very happy to be here. So I'm going to talk about biases because I suppose everybody expects us to talk about biases when talking about ethical issues, but there are all other ethical aspects that should be addressed too, and I'm going to go very quickly on this issue. Next slide, please. So I don't see the slides. I hope I am on the second slide.
Yeah. It's worked perfectly.
Thank you.
What could go wrong?
Yeah, exactly. What could go wrong? Okay, nobody expected that I'd be expelled from the WebEx, but anyway. So what could go wrong? What you see here is an example of an interaction with ChatGPT. And it's a colleague from Berkeley, and he tried to ask ChatGPT to write a function in Python. So Python is a programming language. And this function is supposed to say somebody is a good scientist based on their race and gender. And the answer of ChatGPT is that, of course, you are if you're white and you're male. So this is hugely biased, of course. And, well, although this has been fixed now, if you try that now on ChatGPT, it will not give you that kind of answer. It will answer something like, it's not a good idea to do that for X and Y reason. But it shows that the filters are kind of shallow, okay? That you can, a lot of people are playing that, trying to overcome the filters of ChatGPT. When I say filters, okay, it's a simplification of what's going on there. Next slide, please. But there are much more subtle biases in what we do in AI in general and NLP in particular. If you have a look at the example I am showing now, that's a Google Translate example, you'll see that it looks quite nice, in fact. The first translation, so it's English to French, the first translation is very nice. The two women got married, they gave birth to 2 children, and the translation in French is « Les deux femmes se sont mariées, elles ont donné naissance à 2 enfants ». This is perfect. The second one is very, very similar to the first one. The only difference is that I added a period at the end of the 2 women got married. So now we have 2 sentences instead of just 1. And the translation is very different. We have il instead of elle, which is they in the masculine form instead of they in the feminine form. And this is quite interesting because it shows that this is due to the fact that in NLP, most of the time, we take into account only the sentence. Okay, we start now to go further than that, but the basic unit of processing in NLP is the sentence. And when you split one big sentence into 2, we are not, the technology is still not completely easily able to connect the dots, that is to do the anaphora resolution here between they and the 2 women. Another point is that in French now, the masculine is the neutral case. Okay, next slide. Decisions to define masculine as neutral in French, which was not the case before in ancient French, for example, was made by people. The decision to take the sentence as the context, that's what we're doing most of the time in NLP, was made by people, okay? It's not out of the blue. These were decisions. Next slide, please. Another point is, well, after the neutralization bias, that is, some people are neutralized, now some people are completely invisibilized. And this is the case here. It's image recognition, it's not text, but anyway, you can see that the upper image is with the background, it's on Zoom, and it's with the automatic background that you can add. And you see that one person has disappeared, and this person is black. Okay, that was commented on Twitter. Next slide, please. Another invisibilization, of people is what happens now, happens with the old school deep learning methods like Word2Vec. You had things like discover what is in red, man is to professor as woman is to X, and here the answer is associate professor. So you see that professor women are invisibilized, they don't exist here. I'm showing this, it's some people in NLP would say it's old technology, but it's like 5-year-old, okay? And it has not changed that much today, although, of course, we're making progress. Next slide, please. So again, machine learning is not magic. The decisions to train the systems with stereotyped data sets was made by people, and you heard my colleague Anna Rogers talking about it before me. You can try and do better and do differently. The decisions not to evaluate the systems on black faces, like I showed you, on different accents, okay, that's the case for voice recognition systems, on checking, I don't know, if women are correctly represented. Well, these decisions, although some of them can be implicit decisions, okay, they were made by people. Okay, it's not, again, it's the decision or the lack of decision, but it's still a decision that was made by people. And again, there are counter examples of that because there are people trying, and colleagues in research trying to do better and trying to evaluate on various corpora, various cases, various skin color, various accents, accents from the south of France, accents from different countries, the voices of women, the voices of children, the voices of elderly people. That's very important. Next slide, please. What I hear a lot when I talk about bias is people telling me, okay, but society is biased, and in the end, you know, our tools only mirror these biases, which are already in society. Okay, but the point is, it's not only that we mirror these biases, which is already not so good, but we also amplify them. If you have a look here, it's a nice example I like to show because, again, pictures are easier to show. This is a task when we have to guess who is in the picture, a man or woman, doing what, cooking what, with type of instruments, with which tools. Okay, and in the training set, there were 33% of men as the agent role. 33. But after training a system, bias is amplified, and now man feels 16% of agent roles in cooking images. So the bias is not only mirrored, but it's amplified. So this, I have to say, to be completely transparent with you, this is another system. It's not a deep learning system, but there are other experiences showing that we have the same kind of amplification happening with deep learning system and large language models in particular. So beware, we are not only mirroring, which already is a problem. Okay. Next slide, please. So, okay, now back to the mirror. Are we mirroring society's stereotypes? I heard it at the beginning. I'm sorry, I couldn't hear most of the presentations of my colleagues. I would have loved to, but at the beginning I was there, and I heard that the large language models are trained with some knowledge of the world. Okay, but where do the data come from? The data come from the internet, from the web. And the question is the web the society? And which society it is? Are we representative of the entire world? I don't think so. And the web is not representative of the entire world. Of course not. The vast majority of people expressing themselves on the web are white people, are Occidental people, and they are also in majority male. Listen to what I'm saying. I'm not saying people going on the web. I'm saying people writing on the web, producing content. Okay, so it's highly biased in terms of the representation of the world. If we take the world as our base, then it's not representative of the world, of course. It's representative of the content that's on the web. So what's in there in LLM is not a knowledge of the world. It's a knowledge of a subpart of the world. Next slide, please. We talked about informed consent, so I'm not going too much in details about it, but the content that is used to train large language models is most of the time not freely available, at least from the European legislation point of view. And the consent is not informed. That is, for example, I am showing here the Common Crawl website, where a lot of my colleagues are taking their data from. And it's not really a good idea because Common Crawl, sorry, somebody told me something. No, okay. Because it's not freely available. Okay, it's not because it's on the web and that you can see it, that it's available to train a system, and it's surely not available to redistribute the data. Next slide, please. Okay, another point, I'm not sure it's been told before, it's been said before, is that behind our tools, and it's been a while now in NLP, there are people working. People who do micro-working crowdsourcing. So these people are workers, and they work on different types of platforms, from Amazon Mechanical Turk to Sama Source to Sama now. And they usually work by the task, and they're very, very low paid. This is the case for ChatGPT, and you've probably seen this article from the Time. It's a very well researched article, and they found that Kenyan workers were used by OpenAI to create the filters I was talking about. So that's the human reinforcement learning that you might have heard of in the previous talks, and they participated to that, and they were paid a very little amount of money from our point of view, maybe locally acceptable amount of money to watch and read stuff that you will not want to read and watch. That is very psychologically difficult to address, to process content like, okay, child molesting stuff, or rapes, or very aggressive stuff. Anything you can think of, they had to watch, and they had to refuse or to annotate as negative. Okay, these people were, of course, not well paid, and they were not well followed psychologically. So that's an issue. We are also responsible for the way we're doing this research, for the way we develop the tools. Okay, and that's also the case for us as researchers. So you see, slowly I'm getting you toward the idea that there are not only stereotype biases, there are many other issues. Next slide. So this is an important factor. I'm not sure you heard about this, but the carbon footprint of the training of a large language model is huge. It's been evaluated by colleagues, Strubel et al. In 2019. So the numbers you have to look at in this table is the second one from the top. That's 11,000 something. That's in pounds of CO2. Okay, so that's what we as human being, an average human being, let's say European one, that's what we produce, that's what we consume. And the training of a big transformer with a neural architecture search, that's the last line, is approximately 60 years of a human life. And it was in 2019, and the models got bigger in the meantime. So the training of a system consumes a lot of energy. It also consumes a lot of water. We've heard that lately. There was some research about that lately. So it's not, ecologically speaking, it's not neutral at all. Next slide, please. What we hear sometimes is that, okay, now we have these big models, we don't have to develop so many smaller ones, so it's better from the environmental point of view. Okay, why not? It's not exactly that, and I'm taking here a slide from the presentation of my colleague Emily Bender. This slide shows the different models that were developed between January 2019 and January 2021. And big blue round things are the numbers of parameters, and the square ones are the data sets that were used. If you count all the round blue things, you'll see that there are like 12 models. 12 models were trained during this period. So it's not like we have one big model to unify us all, like in the Lord of the Rings. No, we have many models being developed. And why so? Of course, because there are many reasons why, but one of the main reasons for that is that most of these models are developed by big companies, and they want to show that they are doing better than the other. They are doing bigger, and they are providing better performance for their clients. So it's not the fact that we have one big model and that we, saving carbon footprint and water resources. We are not. Okay, so that this issue of the carbon footprint of AI is not often taken into account. I wanted to show it here. Yes.
Karen, we are running a little bit out of time here. If you could go to the conclusion, I would really appreciate. Thanks.
Okay. Okay, I just go to the slide 76, and I'll be very, very quick with that.
Thank you.
76 is about predictive system, and I really want to go to that to show you that there was a system developed by Amazon to select candidates for their automatically select the CVs, okay? And they realized that the systems only taught himself to select only male candidates. Why so? Because it was trained on the successful previous ones, and the successful previous ones were only male. So next slide, please. My colleague Virginia Dignum says something that's very important that you should have in mind, is that data is about the past. So developing predictive system is the most sure way to repeat what's been done before. And so I'll go over the omnipresence of big tech in the field, but this is a paper we just wrote this year. If you have questions, I can go back to that. The conclusions are in slide 79, is that LLM are trained using data, which belongs to their creators, that is us as people on the web. Large language models are improved thanks to human feedback, that is workers, who should be treated fairly. The issues with large language models are real, and they are present now. They are not in 10,000 years. Maybe there'll be issues in 10,000 years, but I don't really care now. What I care about is what's happening to real people now. And it's not that there is no responsibility that these large language models do things without our consent. In fact, there are people making decisions behind the models. And the things that I could not highlight enough is that predictive systems are dangerous. Thank you very much.
Thanks a lot, Karen. Very, 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 very interesting presentation. We are, however, running a little bit out of time, so I will need to skip the question and actually introduce already the next presenter, Peter Sarlin. Peter is the CEO and co-founder of Silo AI, one of the Europe's largest private AI lab. He is professor of practice in applied machine learning and AI in Aalto University, and associated professor with Imperial College London, London School of Economics, Hall Institute for Economics Research, and the University of Cape Town. He is vice president of the IEEE Computational Finance and Economic Technical Committees, and he will talk about enabling new and boosting existing application. Peter, the floor is yours.
Okay, many thanks. Can you see me and hear me?
We hear you.
Okay, very good.
And we see you now.
Let's move to the next slide. I will talk about applications of AI and especially LLM and Gen AI. And I'd be happy to also answer questions. I'll try to leave a few minutes at the very end. To maybe give you a little bit of background, and I think you've been getting good background for the past few hours already. But what I can sort of maybe bring to the picture here is a perspective that I think is worth noting. We are at the very, very beginning of what this technology will allow and enable us to do. You can compare that to the development of computers or the development of airplanes, we are seeing, the way I put it here, a 2-minute trailer with ChatGPT for the 50-year movie, and most of the plot is not shown yet. And I think this is worth remembering when we are sort of looking at the current state of technology. What are the opportunities and what are also the risks with this technology? Next. The perspective I take to value creation with AI overall is that it happens via digital products, digital services, or digital platforms. Just making sure that the slides can be seen. Yes, good. And I have said this for the past several years. We founded Silo at the end of 2017, about 5 years ago, and ever since we've been building AI as part of digital services and products, and I don't believe this wave is any different. I think it's actually very, very similar. AI or value with AI doesn't happen as sort of standalone pilots, standalone solutions, or just basically by building AI on its own, but it really happens as part of digital services, digital products, and that's the enabler for value creation to happen. That usually requires us to take a long-term perspective to building AI and to building that as a product development initiative and thinking of it as an engagement that you commit to for the long term. It also, in many cases, implies that you can't be sort of, sort of sprinkling a little bit of AI everywhere in the organization. But in most cases, you need to focus on sort of core products, services, or processes of an organization. And in many cases, basically for that to be a business case that is providing you enough return compared to the significant efforts and investments that in many cases it takes. Next. So the way this is this is a quote from an article by Mark Andreessen in Wall Street Journal in 2011, Software is Eating Traditional Industries. And he gave a lot of good examples, Spotify, Amazon, Netflix, for instance. And that relied on the sort of logic behind platform economy, behind network effects, and so forth. What we've seen in the past several years is not only platform economy and network effects, but we've seen model-driven, and that implies AI model-driven business that has been accelerating the extent to which these digital services have been able to position in certain markets where every single user improves the model by every single interaction, and every time you improve the model, you improve the product, you get more users, and so forth. And this I think is exactly the logic that happens with Gen AI and LLMs as well. And this is also the logic with which you can see LLM technology companies or Gen AI technology companies partner up with those digital service companies or digital product companies that have the distribution, have eventually the end users, with which you can basically build a better product with every single interaction. Next. Now, I think in this case where you've already a few hours been listening into, say, LLM and GPT-related topics, I will probably not repeat the terminology here. But what is worth noting is that if you look at ChatGPT, it's just sort of yet another application. And of course, one that is very popular, creates value, and has paved the way for many things. But it's just one custom LLM out there. So, it has a generative pre-trained transformer as a basis. So that's a foundation model that has been fine-tuned for the purpose of conversation, and where especially there's been sort of innovation around reinforcement learning with human feedback for, say, fine-tuning purposes and ensuring that you're creating value for the eventual purpose of conversation. Next. And so the perspective I've taken to sort of ChatGPT as an innovation, especially now from an application perspective, is that it's in itself, it's not you could say that it's not a scientific innovation, but it is a significant product innovation. And again, I think this is very much aligned with the fact that AI is not anything standalone, but it sits as part of digital services and products. And the only way to create value is to ensure that the digital product in itself is creating value. And only then you can create more value with AI. And of course, user experience being the significant value creator in terms of, or at least hypothesized as such, even by the creators itself of ChatGPT as the key differentiator. Then number two focuses on value creation. And I personally strongly believe that value will not be created by these very generic large language models, but by bespoke, by specialized use cases using specialized data, and especially then fine-tuning these base models, generic base models, for very specialized purposes. And eventually, we've highlighted a number of times that this technology will produce significant changes to how we work and live. But I think it's worth noting that there's plenty of the contributions with, for instance, ChatGPT have been actually engineering contributions, how we actually make this work in practice, how we can run such a large model as part of a product where you're expecting low latency, and a number of other engineering topics that I think remain to be solved. So there's plenty still to be done on that end. Next. So sort of my overall takeaways on what it implies to create value with an LLM or Gen AI application relies on sort of these four key takeaways. As I've said, as with other AI, Gen AI or LLMs will become part of digital services and products. What we've seen, I think, can be sort of can be compared to what I previously said as the Tesla effect. When Tesla went out with FSD promises, full self-driving promises, all the other car manufacturers followed. And we saw significant investments into engineering and product innovation. And that obviously implied that there was significant progress. And I think this is what we're seeing, but we're seeing this with respect to software. And I think that is a much, much larger impact than only car manufacturers in itself. I do, and I've said this also before, believe everyone's digital sovereignty is and will continue to be challenged, especially if many of these players contributing to base models and foundation models are closed and are not run out of Europe. And this, I think, especially relates to two things. One is that the base or the foundation models should be open in order for us to be able to create value on top. At least they should be accessible. And I believe the OpenAI community, and I've said this for many months already, and now we can see also partly market following. I believe it's going to be eventually open, but at the same time, not everyone will by default be covered by that. And I think especially in Europe, with a large number of small languages, this is something we should be concerned about. And eventually this relies on the fact that value is created on top. So value will be created via domain-specific downstream applications that relies obviously on having access to base and foundation models, but eventually then allows companies, for instance, European companies, to create proprietary technology as part of their own digital services, products, platforms on top of these open-based models. Next. Now, I will not talk about silo in any other way than basically positioning how I believe sort of applications are happening or how I see applications are happening at the moment and how I believe value should be created. We're basically helping companies build custom bespoke LLMs, relying on open-based models and putting forward a large number of different kind of tooling to be able to create value for a very bespoke purpose. In most cases, what tooling requires is to be able to run data-centric AI development, implying that you can run data annotation initiatives, data generation initiatives that allows you to create such training data or fine-tuning data for your LLM that eventually solves the specific problem at hand. And that is how we believe you create trustworthy, robust, and reliable custom LLMs. Next. I'm going to run through the 3 different application areas that I had on the previous slide. And obviously there's plenty of additional ones or examples to be covered, but maybe this gives you a little bit of a perspective. Automating customer service with conversational user interfaces and even autonomous agents solving those tasks. That obviously as part of a digital platform. The same with, say, content creation. Think of all of those open forms as part of digital services and products. Eventually, as end users, we expect them to be pre-filled or to get help in filling them. The same with the user experience for products overall, be that content search and queries as part of a product. And that could be your ERP or CRM or some other digital service where you're expecting to be able to interact with its knowledge, its content through discussion. Next. Search is an obvious one. Search and query information across the organization. Close to every large company is at the moment considering how they can utilize this technology for their purpose. Can they use ChatGPT and APIs of closed models, or do they have to build out their own technology for this? But then there's a number of other use cases, finding information in knowledge hubs like technical documentation, searching information in various external domain-specific areas, themes, be that news or other sources, and so forth. Next. And then eventually generation. I think this is something that, we are already seeing happening on many different fronts, especially that relates to summarizing text with a specific content or style, generating or summarizing technical documentation, and then, as we've heard many times, generating code from instructions. But with that, I'll end, and if there is time, I'd be happy to take a question or two.
Thanks a lot, Peter. Thanks a lot for this interaction and for this presentation. Maybe a few questions, but we are running out of time. Do you see this LLM mentioned as mainly specialized, truly large LLMs, GPT scale, or do you see more specialized, smaller large language model on this type of llama style and similar scale to be developed? Or do you see both?
Yeah, I think that's a very good question. I personally believe that the future is not going to be about sort of a similar path in just growing the number of parameters and the size of the models. We're already seeing innovation in how you build more efficient models and how you can efficiently fine-tune even smaller models, especially if you go to bespoke specific purposes. You're in many cases fine with the smaller model, and they are eventually much easier to use in practice, which I think is one key element when companies then actually eventually run inference engines. So eventually, I think sort of the future goes towards smaller, and then eventually I would like to see a future with modular models where you can stack multiple different models as per need.
Thanks a lot, Peter. I'm cornered by the time, of course, and there were still tons of questions, like fundamental one, but I'm scared about asking them because it's going to spend an hour or 2 hours of things. There is one like, are LLM a stepping stone to AGI, or do we risk overregulation AI research to death here in Europe? Overregulation, and this kind of open question. But as a conclusion, I would say that this presentation raised a lot of questions. Not all of them are going to be answered now. But being positively minded, I would say that it might be the exact intention of what a crash course is about. Raising interest from the audience, eliciting further questions that you, each auditors, will investigate further. So thanks a lot for the participants, of course, from the speakers, but also the audience. And I would like to mention the last info. Do not forget that tomorrow there is also another Connect University session on communicating digital technology. I really thank you all, speakers and auditors, for this excellent and very interesting session. Thanks a lot, everybody.